Hello, everybody, and welcome to Sparring Partners. Today, we're going to talk about physical AI. And physical AI is more and different from the traditional robotics, where you have a robot that works out there, separate from the network, might require a little bit of connectivity, but not too much. Physical AI is much more deeply embedded in our network infrastructure. And to optimize director behavior and things like that. So that it's a great change. It's an opportunity, but also a challenge because you want to make sure that physical AI works well and doesn't create safety issues. So with me today, I have Yue Wang, and she is a chief technologist at China Telecom. And also, she's been doing a lot of work on AI, but also on ORAN when she is in the board of directors at the ORAN Alliance. So you welcome to Sparring Partners, and let us know a little bit about your background and what you're currently working on.
Yeah, thank you, Monica. Thank you for having me. My name is Yue Wang. I work in China Telecom as a chief technologist and mainly focus on network and AI, what we call the next generation ICT, which is the next generation information and communication technology. So my work is mainly about how to develop the network plus compute capability for the new, for example, AI services and AI applications, because we see AI as a main drive for the next generation network infrastructure.
Excellent. And you've been starting out, well, maybe you've been for a while, but working on physical AI. How do you see physical AI to fit into, our networks, and where does it sit?
Yeah. For me, physical AI is about giving machine the ability to perceive the physical world and to be able to respond and interact with it. So I think the interaction bit is very important for physical AI to fit into the network because there has to be a connection. There has to be a compute for the physical AI to be able to react. If we think about the popular, for example, GPT, large AI model that we are familiar with, chatbots or image recognition, I think physical AI is adding one aspect, which is putting it into the physical world. So it's not just about thinking and getting the knowledge, it's about perceiving and interacting. It's deeply embedded into the network and being able to connect it to the other physical AIs and to be able to interact with the real world.
Yeah, and I guess that one kind of way to look at it is that physical AI has sort of some motor coordination. It moves out there. It exists out there in a way that an LLM model doesn't. An LLM model lives in I don't know, in the cloud or somewhere, but there is no physical instantiation of it. Well, there is in the server, but it doesn't have to move around, and that creates all sorts of issues because clearly safety is an issue everywhere, but it's even more of an issue when you have something, a robot or some physical thing moving around, or I guess a drone too. I mean, when you have something. So how is that changing the way they are, they operate within the network?
When we talk about physical AI, there are two main aspects when I think about how network is going to evolve in order to support physical AI. I think first of all, it is about having the network capabilities. Those capabilities include, for example, uplink capability, the low latency, the deterministic network in order to allow that real interaction of the physical AI between the real world. And then I think another quite critical factor is that in the past, we always want to have, for example, more bandwidth, more users, more data, and we think the better the connectivity is, the more powerful the network is. But I think when it comes to supporting those new AI services, it's actually not just about the network connectivity, it's also about the entire capability of the network. So that means the network needs to be able to combine the connectivity and the compute and to expose the capabilities and to be able to support those AI services. So I think that actually is driving the network from the data driven to data is like the volume of the data. So in the past, that's what we kind of are targeting for the network. So from that data driven to now become the capability driven and the core competitiveness of the network is not only about how much data we transmit in the network, but more about how much core capability we can provide for the AI services.
Well, and I guess as you say, it's the capability. So, I mean, obviously you need to have some capacity, but also, I mean, uplink and downlink, but also latency, reliability. It just changed. It seems like, it definitely increases the requirements of the network. But we should be able to do it, but it doesn't mean necessarily that it's out there and that it is available throughout the footprint. So, is it going to be mostly through, private networks that are specific, like in a factory, you just have its private network, or in public networks? So how do we look at that?
We already see some of the applications of physical AI, for example, robotic arms in factories, where you can, control the robotic arms to move stuff. A good 5G private network is already able to accommodate the robotic arms in the factory. There is already such applications, but I think they don't do very well in, for example, real-time interaction, and they don't do very well in parallel processing. So, for example, if you have a number of robotic arms in the factory, and you need to do this upstreaming of the videos, for example, in a short time, the interaction and the latency is not good enough. So that goes back to the requirement we just mentioned. There are certain capabilities in the network that needs to be improved in order to accommodate those applications. But then I think these requirements, they have to be exposed as a whole. So in the sense that you can't just have very good connectivity, or you can't just have very good latency. You need to have the capability altogether. Otherwise, the weakest link is going to kill your application.
Yeah, and I guess that not just with physical AI, but we have more and more different services that require different capabilities that have to coexist in the same network. So in that respect, is this going to be something that it actually is going to push network slicing to become more of a reality? Because now we have it, but it's just very limited. The deployments are very limited. Maybe this cause a real, like, we really need to do it now.
Yeah. When it comes to network slicing, and also what we call, the guarantee of the QoS for those kind of AI services, it becomes very important to actually differentiate the different services, because as you mentioned, those applications, they require very different network capabilities. So, for example, if I need to enable a robot to run, it's very different requirement for the network compared to handling a cup, for example. And when it comes to network slicing, it requires the network to be able to flexibly allocate the network resources and computational resources according to those requirements. So that makes the requirements much more complicated. And another aspect I wanted to say is that a lot of those applications would require the multimodal AI, and how to actually differentiate the services is becoming critical. And so how to tell, if I have a end user, how to tell if I require, for example, video recognition or voice interaction or machine interaction, because those kind of different services are very different when it comes to the requirement to the network.
And I guess it's sort of like, so it's not only is it physical AI or a human or whatever, the sort of device, or the end user different, but also what the end user is doing. So there are different robots out there, and I guess the same applies to drones and things like that. So now the other thing that we need to think about more is the need to have some of the processing or most of it at the edge. So how do we think about that?
Yeah, I think well, that's another very good point, because at the moment, a lot of machines, they would put for example, GPU at the terminal, in the device itself, and that makes the device heavy, and it consumes more power. And when you actually have the edge computing power, which can be the local brain that complements the physical AI, because if you think about some of the applications like smart glasses, they don't have that much capability to accommodate heavy computation, and they can't handle the complex data processing and those inference tasks locally. So edge computing can actually solve those problems by placing those compute resources close to those terminals. So instead of sending all this data to the remote cloud for processing, which actually causes quite large latency, those edge nodes can handle the real-time computing tasks nearby, so it can achieve a much lower latency. So yeah, I do see edge computing is becoming more and more critical in supporting the physical AI applications, and especially when there are many parallel physical AI applications at the same time.
Yeah, absolutely. So that's actually, so that's great because there is a very good opportunity for the technology. And in China, you guys have been way ahead in terms of introducing that or having also private 5G. And so maybe you can tell us a little bit more about how you see there. And since you also are familiar with what's happening, you're you spend a lot of time in Europe, in the UK. So, how does that compare?
Well, I do see emerging applications of robotics and physical AI. I mean, I've seen examples where in agriculture, those robotics arms can integrate with physical AI, and essentially 5G connect and to be able to monitor their behavior. And another example is the navigation using smart glasses. Maybe smart glasses is precisely is not a category of physical AI, but this is one of the earliest applications. So basically, what you do is in some of the scenery places where you wear the smart glasses and you would be able to see, for example, some of the buildings, and then the smart glasses would be able to return the description of the buildings, the historical information, a story behind it, and then you can ask questions. It can interact with you in real life. So I think those are the great examples where those AI applications are actually changing our lives. And we do see with those physical AI applications in the industrial field, where they can take on the repetitive, highly risk tasks. So, for example, if in a toxic environment, fireplaces, they would be able to help. So I do see those kind of AI applications are emerging, and I think it does need to have a very good network connectivity, as well as the compute capabilities to support them. And when comparing to the UK, when I talk to some of my European friends about, for example, the use of robotic dogs to help you to do grocery shopping, they would think it's a crazy idea, because they would then say, how about if I don't get any connectivity on for the robotic dogs, you won't be able to use it.
Yeah, no. So I saw the demo of the dog for blind people, and it's like, that seems like such a great idea because a dog for a blind person costs like in the UK like 100,000 pounds. It's very expensive, and they don't last forever. So only a few people can have a dog, and there's just so many of them, and so clearly a robot would help. Just and it doesn't displace anybody, or because it's just like it would just provide a service that is not possible. We cannot afford as is. But when it comes to other things where okay, it might be in a sort of a dangerous environment, but also it could be on, the like fulfillment centers, manufacturing. So you're bound to replace a lot of jobs. So how should we think about it? Yes, true that jobs that are repetitive might not be there anymore. So maybe those people will be relieved, but they might not find another job. How should we think about it?
Yeah, that's a good question. Before that, I didn't mention the robotic dogs, right? I mean the one that for blind people. So I might say that a little bit more.
Yeah.
It's actually a very interesting application, because what we found is that in China there are quite a number of people who are visually impaired as well, and they will rely on the guide dogs. Sometimes it's more expensive, they need more attendance. So one of the use cases we developed is, one of the experiments we developed in Shanghai is on the road there is this robotic guide dog, where it would be able to sense and to be able to navigate on the road. So sometimes it sees a obstacle, it would be able to feed back to the blind or the visually impaired person. That was a very interesting one. So I think that's the first step for the physical AI to replace guide dogs, if not human. But to me, I think the core target of having physical AI is not about to create a machine that exactly like humans, but to create a machine that can help and free some of the human tasks. So I mean, we should let the machines do the things that a human can't do, do not want to do, or can't do well, for example, so that humans can have more time to pursue more meaningful creative things. So I am actually looking forward to the day that the robotics can do my laundry, help tidy up the house, and to be able to carry out some of the tasks that I wouldn't feel I wouldn't be bothered to do, really.
Yeah, me too. I'm really looking forward to that day. Well, there is an advantage. Well, there is a benefit in trying to get human-like robots, because once you solve the sort of motor coordination part, for running or dancing or whatever the case may be that might not have that much of a utility in manufacturing directly, but you understand how to do one for, say, any manufacturing job that you have out there. So I guess it's just our ability to have the motor coordination, in whether it's human-like or not. You still need some motor coordination so that the robot actually moves coherently, doesn't do any damage, and things like that. So that's a big challenge. Now let's talk a little bit about the sort of, okay, so the on the network side and the operator side. So clearly we need to get the network to be able to support all those services, but is it worth it? And who's going to put up the money, in a sense that if you do it in an enterprise, in a manufacturing plant, is it going to be the manufacturing company, the operator? How is that going to work, you think, in terms of the business model? And how can you justify the investment that you need?
It is more about for the network to catch up with the AI applications. I think the AI world is evolving so fast. If I remember correctly, like last year, the robots can't run that well, probably can't walk that well. But this year they run like faster than human beings. And so I do think, the AI world is evolving so fast, and that put quite a lot of pressure on the network. And the thing is, if we don't develop the network that is able to accommodate those AI applications, they would be able to find out other way around. To me, I think it is more about making the network relevant to the AI ecosystem.
Well, I mean, it's not, well, you can marginalize the network, but at some point AI, would not run. I mean, if you don't have connectivity, forget it. Right?
Yeah, no, I agree. The thing is, obviously AI applications, they would create loads and loads traffic to the network. So yeah, you would say the network is still very relevant because connectivity is still the foundation. But the thing is, the operators are not making any profit from having more traffic because the network is acting as a pipe. So I think that's where the problem is. It's not because there is no new applications or like new requirement. It is more about we didn't monetize the network capability.
Yeah. Let me ask you a final question. It's only in recent months that people are starting to talk a lot about physical AI. So before it was more LLMs and knowledge workers, some model that can do the coding, and now we talk more about physical AI. Has your view changed in terms of how quickly we are moving? In the same way that LLMs sort of surprised us all, is it physical AI going to surprise us all and say, we thought it would be like 20 years from now, and it's just going to be 2 years?
Yeah, no, I think so. I think actually this year physical AI has surprised me, for the robotics running on the street and runs faster than human being. And I think there was this prediction from NVIDIA in CES 2025. So basically what it says is 2026 is is a year of agentic AI. So this is where the AI agents would call the other AI agents and complete the more complex tasks. And then year 2027 is what NVIDIA predicted as physical AI, the year of physical AI.
Absolutely. Well, thank you so much. This was a very fascinating, it's a fascinating topic, and it looks like it's a great growth. I mean, AI is just it's not one thing; it's just so many things at the same time, moving in different directions, and I think physical AI is going to be really a huge thing. And just think about what we can do. So, keeping our houses clean, first of all.
Absolutely.
Well, thank you so much, and thank you all in the audience for following us, and keep listening, and tell your friends about it. Thanks.